Hello friends, welcome back. Today we'll be going over another Leetcode problem called Alien Dictionary. This is another frequently asked question by Facebook, and this question has also been asked quite a few times by Amazon, Google, Microsoft, Apple, and quite a few other companies. Let's go through the problem description. There is an alien language which uses the Latin alphabet. However, the order among letters are unknown to you. You receive a list of non-empty words from the dictionary where words are sorted lexicographically by the rules of this new language. Derive the order of letters in this language. Let's go through the examples. So in the first example, we see that we have 5 words. The first word is WRT, the second word is WRF, the third is ER, fourth is ETT, and the last one is RFTT. And we have the output as WERTF, which is one of the possible sorted outputs for these letters. So we compare the first two words. We see that WR is common in both of them, and we find one difference between the third characters of these words, which is T and F. And we can confirm that logic by seeing that T is coming before F in the output. Next, we can see that E is coming after W, so we have WE, and similarly we can derive the order between the other characters. Next, in the second example, we see that this is quite a straightforward example. We just have two words or rather two characters, Z and X, and the output is ZX. In the third example, we see that the input is ZX, Z again. Here you see that there is no ordering possible as X comes both before and after Z, and this in a way forms a cycle, and hence we return an empty string. Let's go through the note. So you may also assume all letters are in lowercase. If the order is invalid, return an empty string, like the way we did in the third example. There may be multiple valid order of letters. Return any one of them. So again, if you carefully look at it, it's a problem on graphs, and we would need to perform topological sorting to find out the correct ordering between these words or characters for this language. So if you haven't till now, please see my previous videos on topological sort and course schedule, where I have described in detail how to approach such problems. So initially we'll need to create the graph. Next step would be to find out all the nodes whose in degree is 0 and add them to a queue. And finally we would be popping those nodes one by one from the queue and iterating over their adjacent nodes. And we'll recompute the in degrees, and we'll repeat this process till we have no more nodes left in the queue. So let's try to code it. First, we define an array to hold all the in degrees. Since we know that all the letters are in lowercase, we can just have a simple array of length 26 to hold all the 26 lowercase characters. Next, let's initialize the graph. It will be a graph pointing from characters to a list of characters, and this list will be holding the adjacent nodes for that character. Now let's try to build this graph. So for that we'll have to iterate over all the words and then actually all the characters and put all the unique characters into the graph. So we write for string word in words, and then once we have the word, we'll have to iterate over all the characters of that word. So we write char c in word.toChar array, and we'll put this node c and assign an empty array list as its value. Once we are done with this, we would need to determine the edges, or more specifically to determine the direction of the edges. So for that we'll have to compare words in pairs of two. So we'll start with the first word, compare it with the second, and then second and third word, and so on. And the way to determine the ordering, as already discussed, is to find the first mismatch between those words. So if you think of the normal dictionary, the way it works is pretty similar. So here again, we'll pick first words and see where the mismatch occurs, and we'll form an edge between those two characters. So we write for int I is equal to 0, I less than words dot length minus 1, I plus plus. Now let's say that the first word, let's call it start, and let's call the second word as end. Now we'll only need to iterate till the length of the smaller of these two words. So we can define length as mat.min, start.length, comma end.length. Next we write for j is equal to 0, j less than length, j plus plus. Now let's define the character from the word start as out. By that I mean that an edge is going outwards from the character in the first word to the character in the second word. So char out would be start dot char at j, and char in similarly would be n dot char at j. Now the first instance where out is not equal to in, we can add an edge in the graph. So we do a graph dot get out, which would initially be pointing to an empty array list, and we'll add the node in. Once this is done, we'll update the in degree of node in. So the way to do that is write in degrees. We'll have to typecast it to an integer so that we update the correct position in the array, and we do a plus plus. So here if we see, once we have the node f, we'll be updating the in degree to 1. Our next step would be to add those nodes into the queue whose in degree is now 0. So we initialize a string builder. SB is equal to new string builder. We initialize a queue character is equal to new linked list of characters. Now we'll iterate over the graph. So for char c in graph.keyset, we would need to find out all the nodes with in degree of 0. So we write if in degree of c minus a is equal to 0, then we'll add this node in the queue. And finally, we'll have to iterate over the queue and keep on repeating this process and updating the in degrees till we have iterated over all the nodes. So we write while not of queue dot is empty. Let me just add some space so that the code is visible more properly. We'll poll the first character from the queue. So char out is equal to queue dot poll. We'll be appending this to our string builder. Next, let's iterate over the adjacency list of this node out. So we write for char c in graph.getOut, and then we'll do a minus minus in degree of node c. Actually, let me call this as in so that it makes more sense. We'll have a sense of the directions. So minus minus in degree of in. If this is equal to 0, then we'll add this node into the queue. And we are all done. The only thing remaining is to return our result. So we'll write sb.length if is equal to graph.size. In that case, we have a valid input, and we'll return sb.toString. Else we can return an empty string. Let's try to run this. Okay, so there are some typos. Okay, so we did not handle this case where the second string was a prefix of the first string. In such a case also, the output would be an empty string. So let's quickly handle that as well. So we write if start dot length is greater than end dot length and start dot starts with end. So start dot starts with end would determine if end is a prefix of start, and in such a case we return an empty string. Oh, I mentioned about the break, but I hadn't added it. Let me add that as well, because the moment we find the first mismatch, we do not need to iterate further. Oh, there was another typo. I was saying it starts with, and I've written it as start with. Let me fix that as well. Too many typos today. Sorry. Let's run it one more time. It works. Let's submit it. Great, it works. Thank you guys for watching. I hope you liked the video. And with this video, I'll be concluding our short series on topological sort. Feel free to drop your comments, feedbacks in the comment section below. And also you can suggest any other videos which you want me to make. Please like the video, subscribe to the channel and share it with your friends. Thank you.